Let's take a look at maybe run through these answers and see if we can, if there's any we need to look at volume wise. Then we'll go ahead and look at the 2017 free response. If there's any questions you had on that, that's one of those things that we're going to hand in tomorrow. So I'll give you an opportunity to maybe ask a question or two on those. And then we'll have some work time today. If you need to clean up some of that or finish up some of that, you can do that. And then I've got another packet. So a lot of our assignments going forward are kind of longer term. So just stay on top of that and think about that. I mean, a lot of days, like we had an assignment yesterday for today, right? We have a few of those left as we do a few new things yet, but not a lot. Most of the assignments are going to be a little longer term. So, you want to be thinking, oh, I don't have an assignment tonight. Well, yeah, I do. I need to get a little bit done on this packet that's due next week, a little bit due. So we're not waiting till the night before trying to just fill in stuff or look at the answer book. I mean, I told the other class I was close to banning the answer books anymore because the answer books are here for you to check, kind of see when you're stuck, whatever, not to just take a picture of every page, which I'm okay with you doing if that's how you're using it, but if all you're doing is using that to then on the homework yesterday when I went around and looked at it, like nobody in here asked about 38, 39, I don't think, when we were doing the homework. Those were kind of tough problems. So the work you had, some people had copied down was pretty much just directly out of whatever one of our answer books we have, So, if you're not sure on some of these things, we should talk. It's kind of defeat the purpose. And it really, truly is just busy work. If all you're doing is just going through your phone and looking at the answer and just filling it out so you can hand it a packet, then what are we doing, right? What do we accomplish? Let me read through, or you guys tell me what you had. So, or let me just read through. So 14A is 16 pi, 14B is 128 pi over 5, 14C is 896 pi over 15, 14D is 16 pi over 3. Okay, so there's a lot of good. 2 of those were horizontal strips, 2 of those were vertical strips. A couple of them had empty space, a couple of them didn't, or maybe they all had. A couple of them had empty space, a couple of them didn't. So you had a couple of washers, had a couple of disc or circle slices. So good practice on those. 18. But again, if you had some questions, we should talk about it. Now, I had the answer book. I think their picture was drawn wrong in here. So I don't agree with their answer. So we can talk about that. 18 is 512 pi over 15. And 23 is 384 pi over 5. And then 50 50A is 81 over 10, and B is 9 over 2, and D is, they've got 81 radical 3 over 40 for 50D. 51A is 1/10, 51B is pi over 80, and 51C is radical 3 over 40. Okay, any of those? Which one? 18. Okay, so the reason I think the answer is wrong in the answer book on 18 is it says bounded by y equals x squared and y equals, help me out, y equals 4. Okay, so if we look at this, and then y equals x squared, so 2, 4, 1, 1, right? This parabola would kind of come through. So so to me, this is the region right here. To me, that's the region. Okay, because it simply said bounded by y equals x squared and y equals 4. It didn't say anything about first quadrant only. It didn't say bounded by the y-axis, x equals 0, right? Unless I'm mistaken, isn't that what it said? It just said bounded by y equals x squared and y equals 4. Now you could take the picture that they drew. See, if you looked in the answer book, the picture they drew was just the right half of this. Now you could revolve that and then double it because of symmetry, so that'd be okay. So you could do that, but I think this should be the picture. So if that was on the quiz, remember when we do our quiz on this next week, I don't know, Wednesday or so, sometime middle of next week, we will, Wednesday or Thursday probably, when we revolve that, I mean, you have to draw the correct picture, right? So I'll try to be very, very clear in the directions I give on what's bound, but to me, these directions are pretty clear. Y equals x squared and y equals 4, and to me, that's that region right there, okay? All right, so, and it's revolving around there, so remember, your strip, or it's your radius, there's not going to be any empty space because the other side of this will be up here. Here will be one slice right here. It's solid. It's going to be solid all the way through, no empty space. And so this is your radius. And we were having that discussion. I don't know if it really, Jason, I remember you commenting, or several of you guys were discussing, whether it goes down or it goes up. I mean, it doesn't really matter. If I draw this radius up to here, but then that curve changes, so I don't want to do that. But from here to here, but I still want to do top minus bottom. Now, it turns out that every one of our volume formulas has our strip and we square it, right? It's either radius squared, or it's d squared, or it's s squared, or it's base squared, or whatever. And so our strip, whatever our strips are that we're doing, are always squared. The reason we do top minus bottom is so it's positive, and right minus left so it's positive, right? So when we're doing area, that's very important, right? When we're doing this, since we're squaring it, it turns out to be. Now, so on the AP test, would they count it wrong? Probably not. I mean, you're going to get the same answer, but then they always read the word and look at it. I mean, I would prefer for it to always be top minus bottom, right minus left. So on this one, I would want to see your R to be 4 minus x squared. So this y value minus that y value, okay? And so then it's pi, and then this would go negative 2 to 2, and then it'd be 4 minus x squared. Okay? All right, what else?
50A.
50A. Okay. So 50, so again, they give you these pictures, but sometimes it's almost easier if they don't give it to you. But if it helps a little, that's fine. So let's say they had, so it says find the volume of the solid who's bounded by the graphs of y equals x plus 1, because that's how I'm going to give it to you on the quiz. Y equals x plus 1, y equals x squared minus 1. Now you are going to have your calculators, so you can graph them with your calculators. And perpendicular to the x-axis. Okay, so y equals x plus 1. So we're going to have a line like so. Okay, slope of 1 coming down through here. And y equals x squared minus 1, so that's to be a parabola. So it's going to cross right there. It's going to cross right there. So it's going to go up like so. All right, so here's our region right here. Okay, so coming up off of that base, perpendicular to the x-axis, so that means vertical strips. Okay, we haven't had very many that have been horizontal, but it doesn't matter. I mean, if it's horizontal, we do right minus left, right? And we wouldn't want to, this problem wouldn't be very good with horizontal strips because you have to split it up. So usually with base problems, it wouldn't give you that. Okay, so here's a strip, touches a line on top, parabola on the bottom. Okay, and coming up off of there, what is this, A? Squares. Okay, so again, getting the right picture is the key, I think, and their picture is helpful. It's helpful in seeing the solid, but maybe not in the drawing of it. So I draw my things, get my region. So coming up off of here is a square. Okay, so coming up off here is a square where that is one side of the square. So that strip, which would be top curve, x plus 1, minus bottom curve, which would be x squared minus 1. That is one side of the square. So my area, and that's what goes in here, is my area. Now you could simplify this as be x plus 1 minus x squared. Now make sure you make sure you do that carefully with the minus sign, right? I'm perfectly fine if you don't simplify that because you're afraid that you might mess it up, okay? That would be fine, but it would be, x minus x squared plus 2. I can rearrange it, doesn't really matter, however you write it, but I think I did that okay. All right, so x minus x squared. So that, and then that's got to be squared. So that strip is one side of the square. We square that. That's the area. Remember, area times thickness gives me volume. The integral adds it up. And then that would go from what? That -1 to, what's that point? 3? 2. 2. 2, 3 is that point right there. Okay? So it would look like that right there. Okay? And then what is B? Yeah, okay, so here's a good example. So this is one, I'm not going to give that to you on the quiz, like B, right, rectangle height 1. Did somebody ask about B, right? That's 50 feet. So it says the rectangles of height 1. Now, we just saw though the other day, yesterday, where we had an isosceles triangle coming up off there. So what we have is rectangles of height 1. So that means this strip is one side of the rectangle, and coming up off of there comes up how far? 1. So what will be the area of this rectangle that's coming up off the page? It'll be the strip times 1. Does that make sense? This strip will be like the base of the rectangle, and then there'll be the height of the rectangle, which is 1. So it'll just be the strip, right? So the strip will actually just be the area. So our integral will just be x minus x squared plus 2 dx from -1 to 2. Make sense? So if it's not one of those 5, which I'm not going to make you do on the quiz. The quiz will be one of those 5 we made in our notes. But on the AP test, they often do things like that. And they say, coming up off of their rectangle of height 1, or rectangle of height, they'll give it some value, something that fits in with the problem. Okay, and all you have to do is think, okay, this strip is what part of that shape, and what is the area of that shape. Okay, and if you think of those two things, and you put that into your integral, you'll have. Okay, so that's 50B. What else? Anything else?
51A, like, I was confused, like, why you use vertical strips on that. Because I usually use horizontal, but I don't use vertical.
On 51,
51A.
okay, 51A says the base is bounded by y equals x squared, y equals 0, and x equals 1. Okay, so we got y equals x squared. Is it x cubed? My eyes aren't very good. Okay, x cubed. Okay, and y equals 0, which is the x-axis, x equals 1. Oh, look at my region. Okay, that's awful. So let's magnify that a little bit. So we got a region. We got this region right in here, right? We got that region right there. And which one are you talking about?
51A.
51A. Find the volume of the solid. And these are perpendicular to the y-axis, right? So they have to be horizontal strips. Was that your question?
And then, like, can't you technically go from, like, 0 to 1 x cubed squared? Because then, you'd have the vertical strips, and then you just square that, and you get the rectangle, and you get the square. But then when I did it, I got, like, 1/7 of the right answer.
And the right answer is right. It's similar. Here's why. This is not symmetrical in here. In other words, this piece in here, this x cubed kind of goes pretty flat for a while, and then goes up steeper here. So this isn't a symmetric, like this piece is not the same shape as this. You get what I'm saying? So if you put strips in here, and you had squares coming up off the page, as opposed to strips this way and had squares coming up off the page, it would be a different shape. It would be a different shape. It wouldn't have the same volume.
Yeah.
Does that make sense? Only, now area, see, I think you're confusing that with area.
Yeah.
if area here, we could do horizontal or vertical strips, add up the area. Or we can do horizontal strips and add up the area. Either way, we're getting this area. With volume, we got two different shapes. If you've got slices coming up off of here, the how far off the page they come depends on this value right here, right? And if you do them this way, coming up on, it'd be a different shape. And so it would have a different volume. That's hard to picture.
I see what you're saying.
Yeah, so it wouldn't. So yes, so we have to, when we get one of these base problems, so that's a good question though. When we get one of these base problems and it says the slices are perpendicular to this axis, do it that way. Yeah, do it that way. Now, it's possible you could have a shape that was symmetrical in the sense that the vertical slices or horizontal slices would give you the same volume. But that would be a rare one that had a symmetry about it that would matter. So we have to take this and make it x equals y to the 1/3, like that, or cube root, right? And so we've got to go 1 minus, so our strip, our s for our square would be 1 minus y to the 1/3. So our integral would be that. I think I wrote that right. Is that right? And then 0 to 1. Is that what we get for part A? So that would be the strip, and then that would be squared. Okay. If it's a square. Okay. And then the other parts, B was semicircle, C was equilateral triangle. So semicircle, stick a pi 8 out in front. Semicircle or equilateral triangle, stick out a root 3 over 4 out in front. Okay. So right minus left. Now we didn't get any washer ones on 14. You good on those? I mean, big R, finding big R and little r. I mean, that's the key. I think what's hardest oftentimes about those is, what's hardest about those sometimes is just when you have, we had, I think on that, we had on 14, we had this region right here, right? And if you're revolving around that, where do the strips have to come from? Where do the strips have to come from? The axis revolution, right? Which is this horizontal dashed line. In other words, you're going to have your outer radius is going to be there, and your inner radius is going to be there. It's got to come from the center. Those strips have to come from the center. Okay, because as this revolves around, right, you can see that's your radius of those pieces. So, okay, just make sure we're good on that. All right, well, let's go to that 2017 packet. If I'll give you an opportunity to ask a few questions if you want. I think we can do most of that, probably. 4C might be the one that we would, 4C would be the one that we're probably not prepared to do. Yeah, let's look at that. We haven't done, we will do more here as we get closer to the test. We'll do more with the difference equations. Matter of fact, that's probably our lesson for 4C. Our lesson on Monday is about 4C. Okay, which is kind of one of the last things we have to do on Friday, or no, Wednesday of this week. Tomorrow, I guess, we're going to do another volume thing, and so we're going to do that on Wednesday, and then we got several new things yet. And probably Friday, and then next Monday, and review, and maybe quiz by next Wednesday. And then our first final, I don't know that we'll do it at the end of, we won't do it, we won't do it at the end of next week. We'll see. We might stick another review day in there. So I'm not sure exactly. But anyway, sometime Wednesday, Thursday, somewhere in there will be our quiz next week. Okay, so let's, so you're talking about part B?
Yeah.
Okay, so at the time T, boil potatoes taken from pot stove, electrical and kitchen internal temperature is 91 degrees at time 0. Internal temperature of the potato is 27 degrees for all times greater than 0. So the internal temperature can be modeled by this function. So it's left to cool, so it starts at 91 degrees. It's always going to stay above 27. It kind of sounds like a Newton's law of cooling to me a little bit, right? Matter of fact, that is, if you remember, that is Newton's law of cooling. Okay, Newton's law of cooling is now this isn't. That's why we can't solve this. But Newton's law of cooling, if you remember, was y prime was a temperature, and it was K, and then it was y minus T. And what was big T? Remember with the coffee cooling? Y was the temperature of the coffee. What was big T? The room temperature. The room temperature, right? And it's going to come down and it's going to level off at room temperature and stay. And so that's what it's saying right here. It's going to stay right. So there's your room temperature right there. Well, if you remember, the solution to that was y. Now, I don't think we need that. We don't need that for part B, but I'm just kind of reviewing some things. The solution to Newton's law of cooling was this right here. Okay. Now, the lesson we do next week, we're going to learn how we can solve it, how we can get from here to there. Right? So when we get to a problem like this, we're not going to have to memorize it if we need it. Okay. So that would be the solution of this, where the big T would be a 27. Okay, and then the negative 1/4 would be the K. All right, and so we would have everything but the A, but then we got the initial temperature, so then we can get that too. Right, so we should be able to find all that. Now we don't need it, and we don't need it for part A or B, and then for part C, we don't get to use the H equation. They want to use this one. Okay, so we'll just kind of skip C for right now. All right, so anyway. To B. What does this mean? Second derivative, right? H double prime. Well, they've already given us H prime. H prime is negative 1/4. I'm going to distribute that. H plus 27 fourths, right? So so this is part B now. So this is H prime. Now, it's with respect to T, right? It's with respect to T. It says right there. We want to do the second derivative. So we just go right from here. So what's H double prime? Now, you don't want to do it in here. I mean, you got room down below where you can do this. But so what's H double prime? Well, we do the derivative of this. Well, what's the derivative of negative 1/4 H? Negative 1/4 H prime, because we're doing the derivative with respect to T, right? Not with respect to H. So negative 1/4 H prime, and then the derivative of 27 fourths is just gone. Okay, well, we don't want to leave it like that. What can we replace the H prime with? This up here. So we're going to take negative 1/4 times this. So H double prime is going to be all of this times negative 1/4. So that'd be positive 1/16 H plus minus, and then negative, so that'd be minus 27/16, right? Wouldn't that be right? Take negative 1/4 times this, that'd be 1/16 H, and then that would be minus 27/16, yeah. Okay, so there's H double prime right there. Use H double prime to determine whether your answer in part A is an under or over estimate of the internal temperature at time t equals 3. Okay? Well, we probably have to go back to part A. See if you even remember the connection here, what they're asking. How can H double prime, and it is related to what you did in part A. What information does H double prime usually give us? Concavity. And how can concavity play a role, thinking to part A now, in over and under estimates? The tangent line in a concave down is going to be above the curve. And in a concave up, the tangent line is going to be below the curve. So let's go back and revisit what you did in part A. Write an equation for the tangent line at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. Okay, so what do we need to do a tangent line? Need a point and a slope. So we need to point at 0, because that's where they want us to do it. And we need the slope. And so what's h prime at 0? So what is the point? 0, 91. And then how do we find the slope at that point? So plug it into h prime, which is right here. So what are we going to plug in? 0? No, we're going to plug in 91. There's no t. T would go in for 0 would go in for the t. 91 goes in for the h. So 91, and is this a calculator one? And this is no calculator, I think, right? This is no calculator. So 91 minus 27, that would be what? 60, no.
64.
Yeah, 64. 64, right? Times negative 1/4, that's negative 16. Okay, so we can write the tangent line equation. That would be y equals negative 16 t minus 0 plus 91, which of course would just be y equals negative 16t plus 91, right? So that would be like our tangent line over here. Now clearly it goes down, but who cares, whatever, doesn't matter, okay? So that's our tangent line at 0. So at 0, the h graph and the y graph, the line, share the same point, 0, 91. But at other places they don't. So use this equation to approximate the internal temperature at t equals 3. So what are you going to do? You're going to put a 3 in there for t, right? So put a 3 in there, that'd be negative 48 plus 91. What's that? 43. So y of 3, not h of 3, right? But y of 3, we get, what did we say, 43 degrees, right? So what that means is we took our tangent line, which touches the graph at 0, because that's where we did the tangent line at, and then we used that to see what the temperature would be at 3. So that 43 that we just found is like this point right here. So now do you see how part B, the question is this 43 an overestimate of the true temperature? Or is it an underestimate of the true temperature? Well, it depends on the concavity. So what are we going to do? We're going to figure out the concavity. So what do we plug in to our H double prime? No. No. Right here? Well, 43 is not a point on the H graph. It's a point on the Y graph. Actually, it probably doesn't matter at this point, right? We could put in 43. We could also put in, because to be honest, we could solve this and set it equal to 0. But we could do the concavity at t equals 0, but I see what you guys are saying. You want to do the concavity at 3, right? And at 3, our approximation of the temperature is 43. So put a 43 in here, that's fine. 43/16 minus 27/16 is what? I don't even care what it is, other than it's positive, right? What I was going to say is you can put a 91 in there. Now, you're right, 91's farther away. 91 would be the concavity here. We'd really like to know the concavity at 3, right? Okay, so by putting in a 43 here, that's not really an H value, right? That's on the tangent line, not on the curve, okay? But I think it's going to maintain that concavity. The only time this turns negative is before if H is littler than 27, right? Right, if H is littler than 27, you'd have like 20/16 minus 27/16, and then that would be a negative, right? So 43, 91, whatever. So put a 91 in here, you get a positive. Put a 43 in here, you get a positive. The bottom line is the graph is concave up, and it says, so use this to determine. So if you put in a 43, if you put in a 91, we can tell that the H graph's concave up, so concave up means that. So which one is it? It's an underestimate. It's an underestimate. Okay, that's how we work with that. So we haven't done much with differential equations. We do have some time, dedicated to that here in the future coming up, where we do kind of like this packet, the step-by-step packet. Let us go back and revisit max min chart stuff, right? We gotta come back to some of these major concepts and work with them a little bit. Yeah.
For the AP test, would they want us to would they be okay with using the class function for you here, or would they want us to solve the anti?
No, no, I don't think you would have to find that. I mean, I really think what you want to put in there is 91. You put in 91 and you see the concavity here, right? What is the concavity where it's touching, where the tangent line is touching, and so that's, and you could argue, but then that 3 is a ways away, so what if it goes back down the other way, if there's a change? But we can tell easily that it's not going to change concavity until we can set this equal to 0, right? And we can see what H value, and that'd be an H of 27 when the temp is 27. So it's, and what did it say here? The temp's always going to stay above 27, right? It's always above 27. So not until the temperature gets to 27 would you have they go to negative. So it's not going to change concavity. It's going to stay concave up the whole time. So I really think the 91 is what we would have wanted to use for, because that's a value to know for. Okay? Anything else? Oh, okay.
The very last one.
Okay. C. Okay, if the function g, and I'll get you down the road a little bit, I'm probably not going to go all the way. What did you do? What have you done so far?
Not much.
Okay. So, the only difference between this and the one up above is the k, right? The k value in there. Okay. So if this has a critical point at x equals pi, so by critical point we mean what? Either the derivative 0 or undefined, right? So find the value k and determine whether the point pi, g pi is the local max, local min, or neither. Show the NASA that you conclude. So a good starting point would be what? Do the derivative, right? So we're going to want the derivative. Okay, so 1 over x plus 1 minus, and the derivative inside is just 1. And then k times cosine x, right? Okay. So now, and you might say, well, okay, look at the derivative. It would be undefined if x is -1, but x can't be -1 because look at the original. You put a -1 there, ln 0. There is no ln 0, right? So x has to be greater than -1 in this problem. So x can't be. If x is -1 or less than that, then this would be undefined when functions undefined. So you know x is going to be greater than -1. So we have to worry about that being undefined anywhere. So now, what do you want to do? Do what? Plug in pi, right? Because they tell you there's a critical point at pi. Okay? So now you can plug in a pi right here and a pi right here, and that set it equal to 0. And then that'll allow you to solve for k. Okay? And I'm going to stop there. So once you know what k is, now you've got this equation. Okay? Now you've got this equation, and now, well, in your derivative, then you can plug it right back into here. So now all you need to do is do a number line, and then see if it's local. Okay. All right. So, and now you can work together here a little bit on those to be finishing those up if you need to. But I'm going to go ahead and pass this out now. So on Thursday is going to be a work day. And I've got another free response packet that I'm going to hand out that's going to be due next week sometime. Okay. So again, it's one of those where we just work on a little bit on days where we don't have homework. if we don't have a regular homework assignment, you work on this packet a little bit, work on the pre-response kind of thing. Now, we're gonna have quite a few days in a row, where we're focused on finishing up chapter 7. So the stuff I'm giving you this week is probably not due for a couple weeks. But again, the danger, it seems like whenever I say something not due for a couple weeks, you just forget about it for, the tendency might be to forget about it until like a day before it's due and then that's when we just start copying out the answer book, and I don't think that gets us anything. So on days when we have work days or days there's not an assignment, the idea is that your assignment is to keep working, to be working in the longer term things. Okay. All right. So this sample 4, so that'll be due at some point, a couple weeks from now, once we are getting closer to our finals. Okay. But tomorrow, those 2 things, if you're good on those, you can start working on it.
If we're taking the AP test, do you think we need to be doing more stuff or just the stuff we're in class?
Yeah. Here's what I'll suggest for those people who take the AP test, mostly because the AP test is a week later this year. So usually our finals wrap up right like the day before the AP test, so we've done our packets and we've got those. This year, I think, since it's a week later, I kind of toyed around with the idea of adjusting what we do. Like the last week or so, we usually work on just some in-class stuff that's not really related to the AP test, because usually the AP test is over. But the problem would be, then that would mean doing some of that stuff not related to the AP test before we take our finals too, and I'm not sure that's a smart thing. So I think what we'll do is we'll just keep doing our normal stuff. We'll get done with our finals, and then for you guys taking the AP test, probably what I'll do, so we'll continue working on their stuff. So I'll have like one more packet that I can give you, be an optional thing, but it'd be something just to stay sharp with things that last week, really. But no, I think for the AP test, that's kind of what we're gearing towards is our finals, which is, and the final is just like an AP test. So I think all of that's going to head ready to go. That's the plan. That's the plan. So they did get all that information to you about the AP test and everything eventually. Okay. All right. So work time the rest of the time. On the finishing up the 2 things are due tomorrow, and then get started here. Sample. Okay, anytime you do a local max min, that's where you have to say, okay, it's positive before and negative after, so therefore, the derivative is positive before and negative after, so therefore the function is increasing before and decreasing after. Therefore, it's local max. And if you're doing concavity, then you have to say it's positive before and negative after, so therefore the original function is concave up, and it's switching the concave down, so therefore it's inflection.
Okay. So include that along with
Yes, the number line itself isn't good. Oh, and also, on absolute max and min, in the step-by-step packet, for example. So we were just talking about this. If it asks for a local max, so like on this one, Jace, this one we were just talking about, it says show the analysis and tell if it's a local max or min. So remember, and especially for the final, and I'm not sure, I'm going to look for it when I look at this step-by-step too, but this isn't worth near the points that like the final exam is. If you get a problem like this, I don't know what this one does, but let's say it does that, right? And you're going to say, okay, this is a local max. Remember, relative max means the same as local max. If you're going to say this is a local max at x equals pi, remember how you had to write that. G prime changes positive to negative, so G changes increasing to decreasing. That's why that's a local max. Remember that stuff? And the same thing went with inflection points. If you had a second derivative number line, changes positive to negative, so G changes concave up to concave down. And then also with absolute max and min, list of candidates. But remember what we said if you only had one candidate? Remember how we used the word always here? Right? If you only had one candidate and there were no endpoints, you could say that the graph, that the G prime is always positive before pi and always negative after pi. So therefore G is always increasing and then always decreasing. So therefore that's an absolute max. Does it make sense? If you know what I mean? If your graph it just goes up and down, that's an absolute max. So your list of candidates doesn't make sense. You can do a number line for an absolute max-min problem or global max-min problem, but you'd have to use the word always in there, right? And so that is important, yeah. So those are all the kind of things we're going to be brushing up on here and making sure we're ready to go.
Second one.